I'm going to note here that calcium hydroxide, strontium hydroxide, and barium hydroxide are strong electrolytes, but they have limited solubilities. This means that if you put a big chunk of any of these into water, little of the chunk will dissolve, but the little that does dissolve will float around as X2 plus and OH minus, not as XOH2 aqueous. In other words, the amount that does dissolve will float around as ions, not as neutral particles. Now the good news is that we're going to deal with solubility equilibria in a later unit. Unless we're otherwise directed, we are going to assume 100% dissociation for any of these substances. Let's do an example on the next slide. We're going to find the pH of a 0.0034 molar solution of calcium hydroxide. Calcium hydroxide has that formula. Unless we're told otherwise, we are to assume that it dissociates 100%. The problem kind of implies that we have 0.0034 molar calcium hydroxide and no calcium ions and no hydroxide ions floating free in the solution. But because calcium hydroxide is a strong base, we are to assume 100% dissociation, which means what's in the solution is basically zero neutral calcium hydroxide molecules and 0.0034 molar calcium ion and 0.0068 molar hydroxide ion. And that's because of the coefficient in our equation. 1 calcium hydroxide produces 1 calcium ion and 2 hydroxides. So be very careful. The hydroxide concentration here is not 0.0034 but rather 0.0068. We're going to be like Ron Swanson with regard to that calcium ion and say don't even care, because that is not going to affect the pH. The hydroxide ion will affect the pH. Let's calculate the pOH, which is the negative log of the hydroxide ion concentration, and we get a pOH of 2.17. The question is not what's the pOH, the question is what's the pH. And since the sum of those two at 25 degrees Celsius, which we're going to assume we are at, is equal to 14, then we can easily find the pH to be 11.83. And we would expect a pH higher than 7 for some sort of a basic solution.